Cloud computing is built on virtualization in most cases. We'll take a look in this video about what virtualization is, how it works, and how it benefits your organization, both in the data center or in the cloud. So what is virtualization? Well, in general terms and philosophically, virtualization is about the idea of decoupling, unlinking one component of a thing from another, and then hiding the implementation of that underlying thing from the higher level operations. Now in computing, virtual machines or virtualization has been around in various forms for actually quite some time. The earliest 16-bit processors emulated 8-bit processors. Virtual printing stacks and virtual modems and virtual APIs are part of most modern operating systems and have been for a number of years. In other words, a monolithic architecture is not commonly used anymore. A monolithic architecture is where everything is top to bottom in one big black box of a thing. Instead, most architectures are some form of stack. Networks are stacks, printing is stacks, and virtualization is a stack, where various levels of components talk to components above them in the stack and below them in the stack. When we look at virtualization in a more practical sense, particularly as it impacts cloud computing, it's mostly about emulating hardware in software. In other words, instead of having a hardware router, you may have a software algorithm that takes care of routing. This allows for things like sharing resources more effectively. It also lets us stop and start computers, or virtual computers, or services as needed and on demand. And importantly to most businesses, removes the need to pay for resources that aren't in use or aren't needed. The main component of virtualization these days is called a virtual machine or a VM. And this is a complete computer emulated and self-contained within another computer. Now, when we talk about one being included in another, usually there's a higher powered host computer or server. And usually there's multiple guests or multiple virtual machines running on that one higher powered server. So yes, you could say that each one is self-contained within another, but in reality there are many running at the same time on a larger, more capable server. The software running on that host that manages and shares the resources of the host is called a hypervisor. The two most common are probably Microsoft's Hyper-V product and VMware's hypervisor. They're certainly common examples, although large cloud providers often have proprietary customized hypervisors meant specifically to meet their needs in their environment. Virtualization can give us a number of advantages. Just in terms of a top 10, things like energy savings, less hardware to do the computing, less energy being used for idle computers, smaller data centers in terms of their physical footprint, and again their draw on energy and cooling and building space, easier testing and analysis, faster provisioning, that one's especially important in a cloud scenario, less lock-in to a particular hardware vendor. If your virtual machine is geared for a particular hypervisor, it doesn't matter whose hardware is hosting that hypervisor, your virtual machine can move around. It can lead to increased uptime by giving you easier ways to build in redundancy or high availability, and likewise can give you shorter recovery time in the unfortunate event of some kind of disaster or business continuity interruption. It also allows for isolated applications. And this refers to the idea of having a separate computer to do each task. This was not usually practical in most environments in a purely physical environment. Buying a separate dedicated server computer for every little function would be very cost prohibitive. However, in a virtualized environment, it's much simpler to create a new virtual machine to host that one particular workload or that one particular service. So you'll find people are not sharing their web servers with their DNS server, with their domain controller in a virtual environment, whereas in a physical environment, they might have all of those services running on a single computer. Now, in one sense, it is still running on a single computer, but it's running in an isolated way with each application or service seeing their own virtual machine. It also lets us extend the life for legacy applications, because as you want to move your network along and grow into the next realm of computing that's coming down the pipe, and you have those 1 or 2 or 4 essential applications that you just can't get rid of yet, you can run them in a virtual environment, perhaps on an older or even potentially unsupported OS. It also allows, as we alluded to with the lock-in statement, more portability of services or computers between different hosts or different servers, between different geographic locations or different data centers, or even up to the cloud. So there's a lot of advantages that can be found by looking at virtualization. So what is it that can be virtualized? Well, servers are probably where most people start. We can also virtualize desktops, particularly with the virtual desktop infrastructure or VDI type of model. We can virtualize storage, and storage virtualization takes on often the particular role of thin provisioning. With a virtual model, we can tell the application or the operating system that it has 2 terabytes of data. But until it actually goes to use those terabytes of data, we're just telling the operating system it's available. It might or might not actually exist, but we're telling the application or the operating system the maximum amount that it can have, allowing it to be added as necessary and shared as appropriate. We can also virtualize networking. There's a push to say anything as a service, and that by extension means anything in a virtual environment. If it can be housed in a data center, if it can be run on physical hardware, you can be pretty sure that if it hasn't been virtualized somewhere already, there's somebody working on a way to virtualize it. What kind of scenarios are people doing with virtualization? Virtualization often begins with server consolidation, the idea of cutting down on the number of physical servers required for those power and space and heating and cooling savings that we were talking about earlier. It's also a great way to do testing, quality assurance, and development labs in a virtual environment. Branch offices are great candidates for that application isolation where someone wants to add an additional service into the branch, but they don't want to dedicate a new server. But perhaps they're prepared to virtualize it on the existing server. High availability, in particular, rolling updates, where you may have a number of web servers and they require periodic updating. By moving the workloads around, by having them virtualized, we can update various components while moving the workload over to somewhere else, and then moving it back to its original location once our updates are completed. We may be able to simplify the infrastructure. Less cabling may be required, simpler designs. Support for multi-tenancy, whether you're a client who is purchasing services from an organization that supports many such clients, or whether you're offering services to multiple clients and users and you want to keep them separated and isolated. The idea of multi-tenancy is well supported by virtualization. And there are many other scenarios. People are finding new ways to use virtualization in all sorts of creative and exciting ways to further their business goals. One way to look at things sometimes is with the single box paradigm. The idea of combining network elements and servers into a single virtual environment, often on one physical server, giving you a complete network in one place. Now, this may not be a complete network enough to run a global business with hundreds of thousands of users, but it might be a complete one-stop shop, so to speak, for your test lab, your QA, a development environment, or a small or medium business, or a service offered by a small or medium business. So the single box paradigm is very popular. It becomes very easy to ship, to install, to maintain, to house where needed because of all of the elements being combined in a virtual way on that one server. We mentioned multi-tenancy and isolation. Virtualization makes it easier to host workloads that belong to different clients, maybe even competitors of each other, on the same hardware. Now, there's some caveats here. It depends on isolation and security to be effective. In other words, if you're having multiple tenants, multiple companies running on the same server hardware, the same physical chips that are actually moving the bits around, then you have to have isolation between them. No one wants their data accidentally or otherwise accessed by their competitor or by a stranger. That means that the hypervisor in use must be solid and secure, as most of the major ones are. but you need to understand how multi-tenancy works and how security is implemented. And that leads to the fact that there are certain practices and standards that must be in place on the human side. You have to have the right policies, you have to have the right procedures, you have to know how to approach it and use those best practices to ensure that the isolation and security is effective in your multi-tenancy environment. In summary then, without virtualization, cloud implementations of platform as a service or infrastructure service would be impossible. You could not offer those without virtualization. Without virtualization, implementing software as a service, such as a web mail client, would be difficult to do, but it might be possible. Virtualization is definitely an enabler for the cloud. Without virtualization, the cloud as we know it would not exist. But virtualization can also bring benefits in a non-cloud environment, such as a traditional data center.